Okay. My today's topic of discussion is obviously this Fourier series and Fourier series. What is a Fourier series? First, let us consider these things because in several problem in physics, rather I can say that in almost everywhere we are familiar to use the periodic function. Periodic function means a function fx that is repeated its same form after a certain interval of time. So if these things happens, that means if x repeats itself after a certain time t, a certain variable t, then this function is said to be a periodic function with period of t. Now, in almost everywhere, this as we are encountered with this periodic function, so Fourier analysis is which can be widely used in many of the fields of physics. That means in case of acoustics, in case of I can say optics, in case of electricity, in case of communication system of electronics, we are using this Fourier series. Even in quantum mechanics, we are using this Fourier series. Now, what is a periodic function? Let's have a very first introduction. Say, for example, if x plus t equal to x. Not only that, for this function, again, this will be x plus yc equal to x plus n times t, where n is some integer, right? So if n is some integer, in this case, this function is said to have a periodicity of p. Okay, so now this function, as this is a positive direction movement of time, at the same time, if you say that is equal to x minus 1 t, if x minus n times t equal to 8, then this function is also a periodic function. So I have already learned about what is the periodic function. As for example, you can see that sin x, if you draw the curve of sin x has a form of what is in this form. If this is x direction, this is obviously sin x, you will see that at x equal to 0, sin x equal to 0, at x equal to pi by 2, sin x is maximum, x equal to pi, sin x is again 0. So the function is like this. Okay. So we repeat its form after a certain period of time. So this is the time period. From this point to this point, this is the period of repetition. Okay. Now, very important property of this function is that if you integrate under a curve, that means, say for example, this is a sine curve, okay, and integrate of this curve within a constant interval of time, that means, say for example, if you are going to integrate the function from this point A to this point B. Now this is the region of integration or the value is just the area under this curve between these 2 points A and B. Now shift this point up to a constant period. That means if shift this A to A plus B to B plus B. Right? Now if you shift this point to this part, the integral remains the same. So I can write integral under of fx a periodic function if I change the interval from t to t plus some other point, then the area under this curve remains the same. Right? Now, what is a Fourier series? A Fourier series is that, say for example, the function is a periodic function, or a function have certain number of discontinuity in its range of interval. That means it is the closest interval between these 2 points. So for example, the simplest example is this is the closer interval minus 5 plus 5. Okay, now within this period of interval, if the function is periodic, say for example this is x, then this periodic function can be represented as the sum of a series sine function or a series cosine function, right? So if x can be represented as a0 by 2 plus, I have already said that it's a series of sine and cosine functions. So let us introduce an infinite series equal to 1 to infinity, and this will be anything cos nx plus bn sin x, where this a0, an and bn, they are the Fourier coefficients. Right? Now, this cosine series, if you put n equal to 1 to infinity, you can extend this cosine series, and if you expand this sine series, you can not sine a, sine b, sine 3x, etc. You have to calculate what are the actual values of this coefficient in b and bz. Okay, so how can you derive this 3 term in bn and this series? Now, first I am just writing the term. The value of a0 is 1 upon pi integral minus pi to pi fx dx. I come to this a0 term in a later time. Now, a in, obviously this is interval between pi to plus pi to minus pi. Now this a in will be 1 upon pi integral minus pi to pi, as this is fx. So fx this times cos nx into x. And similarly, this in 1 to is a 2. And obviously, the coefficient bn will be 1 upon pi minus pi to pi fx sin x into dx, where n equal to 1. this one, right? So these three coefficients I have to, if you know the form of this fx, which is a periodic function, you just put this fx here, here and here, and you have to derive the form of this coefficients a0, n and bn in terms of this summation series, and you put here to get the complete form of this Fourier series. Now, there are some way to derive this function a0, a and b. Let us come to that part. How this function a0, a and b have got this form. So let us assume fx is a function which is found within this period of interval minus pi to plus pi. Now, if you integrate this fx, it is a form a0 by 2 a in cos nx plus b in sin x. Now, if you integrate in both sides from interval minus pi to pi plus pi, what will you get? Minus pi to plus pi afx dx. This will be a0 divided by 2 minus pi to plus pi. This into dx plus sum over equal to 1 infinity. Integrate minus pi to pi plus pi in cos nx plus b in sin nx. So you just put this fx here and you will get the sum. Now, what is the value of this cos x? This will be turned into sin nx divided by n. Now, if we put the value of that particular minus pi plus pi interval, the integration of this term gives me 0. Right? At the same time, integration of this term will be give you 0. So, what is the ultimate form of this? This will be a0 by 2 times cos pi. So, this equal to 2 times pi. So, the value of a0 is 1 over pi integral minus pi to plus pi. This will be fx into dx. Okay. So, these are the first coefficient a0, whose value is 1 upon pi integral minus pi to plus pi dx dx. Now, let us come to the coefficient this a in. Now, I keep this term here and multiply both sides with cos x. Now, if you multiply both sides with cos x, what will you get? And integrate it over from minus pi to plus pi, then you will get minus pi to plus pi fx cos nx, or rather I can say there will be some problem here. So just put it dummy index, which is completely different from this n, that is nx here. N may not be equal to n, or may not be equal to n, or may not be equal to dx equal to a0 by 2 cos nx dx plus sum over n equal to 1 to infinity minus pi to pi cos nx or nx dx plus n equal to 1 to infinity minus pi to plus pi times this will be bn sin nx cos nx. Now if we integrate this term, this will be sin n plus n minus sin n minus n. Okay, this sin n into cos nx. So if you split this term into a series, that is sin n plus n by 2 into x and sin n minus n by 2 into x, this gives me two sine functions, sum of two sine functions. So these are sum of two sine functions. And if you integrate this sine function from minus pi to plus pi, we get this term in this equation. Right? So automatically the first this term will be 0. And at the same time, this term cos nx dx, this will give me sin nx dx like. So again, this is the sine function. So minus pi to plus pi is obviously 0. Now there are only two terms. On the left hand side, this value depends on this function fx. And the right hand side term, from which I have to calculate the value of this a, right? So how can you calculate this? I have to just omit other terms only. Keep this term minus pi to plus pi cos nx, and this equals to this. Right? Now, what is the value of this cos nx into cos nx? Right. This is obviously a delta function, and the value of this cos nx, this will be n times into pi when this n equals to n. So I can write an into pi times delta n. So this delta is directly. Okay. So if this is direct delta function, obviously when n equal to n, then this terms gives me an times pi n equal to. So an equal to 1 upon pi minus pi to pi x cos nx. Right? So this an, as n is the dummy index, we can replace this n by n anywhere. So an will be 1 upon pi minus pi to plus pi x into cos nx times x. Right? In a similar way, if you try to calculate what are the value of this Pn, now you have to integrate this same thing from minus pi to plus pi and just apply sin nx dx. Then this will begin a0 by 2 minus pi to plus pi sin nx dx sum over n equal to 1 to infinity integral minus pi to plus pi n cos nx sin nx dx plus sum over n equal to 1 to infinity minus pi to plus pi being sine nx dx. Right? Now, if you see, this is a cross term. Sine and cos appear at the same term. So, this is again gives me 0 in a complete period of time. And this term again is a sine function. So, if we just integrate this term, we give me 0. And obviously, the value of this left hand side depends on the function effects. What are the form of these effects? Now, if we integrate from n equal to 1 to infinity of this series, this will gives me just dn into pi into n. Okay, so if delta n equal to n, then this when n equal to n, this will gives me bn times pi, right? So bn here this bn is equal to 1 by pi minus pi to plus pi fx sine nx. Okay, if this is n, this is bn, this is sine nx, right? So the complete term of this Fourier series I can write here. This will be 1 upon twice pi minus pi to pi fx dx plus sum over n equal to 1 to infinity integral minus pi to plus pi a n of fx. This will be 1 upon pi. Sorry, this is not fx. This is fx cos nx dx plus sum over 1 upon pi again a equal to 1 to infinity minus pi to plus pi fx cos nx into cos nx. It will be sine term, so sine nx. So this is the complete representation of a Fourier series. Okay. Now here are some theorems that how can you integrate, how can you get a Fourier series, though there exists some finite number of discontinuities in the proposed function which are used for the expansion of this Fourier series. Okay. Now consider a theorem which is nothing but the Dirichlet's theorem. Okay. What is the statement of this theorem? If a function fx, this is well defined, this function fx must be a well defined function, and obviously this function is bounded within an interval minus pi to plus pi. So if the bounded function within the interval minus pi to plus pi, and it has got a finite number of maxima or minima. The function has got finite number of maxima or minima. So these are the condition of this fx that is well defined, that is bounded, and that have a finite number of what I should say maximum or minimum. Then this function satisfies, or there is another term, that is it has got finite, I have just got it mentioned, finite number of discontinuity. Okay, so finite number of discontinuity present, and though the function is a periodic function, then the value of this function at any point x can be the sum of this x plus or x. That is, if this is a function here, say for example, this is a function x, it's a periodic function, and there exists x equal to at point this x equal to a, there exists a discontinuity. Then the value of this function at this point of discontinuity must have the average value of x plus, that's a plus, and obviously x minus, that's a minus. This is the average value I have to take at this discontinuous point. Okay, so this is the Dirichlet's theorem, and obviously there exists some Dirichlet condition that function that can have a Fourier series expansion if fx is at number 1 well defined okay, so fx is well defined function and bounded. Second is that the function is continuous or piecewise continuous. Function is continuous or piecewise continuous, or the function, what is the meaning of this piecewise continuous? Because the function had finite number of discontinuities. Okay, then the function is said to be a piecewise continuous function, and the function must satisfy this periodic condition. So, periodic condition must be satisfied by this function. If this three quality satisfies by any function fx, that can be expanded in terms of Fourier series, as I mentioned in this class. Right? So, now come to the an example of this Fourier series expansion. Say for example, function fx example. Equal to x square. Now, this x square, this is a bound between the interval minus pi plus pi. Now, how can you expand this fx in terms of this Fourier series? So, you have to first calculate the values of this a0, an, bn. What are the value of this a0? A0 will be, so first we can do x square, we can write this function, sum over a equal to 1 to infinity, this will be a of x plus b sum x. Now we have to calculate this a0. This will be 1 upon pi minus pi to plus pi if x into x. So this will be 1 upon pi minus pi to plus pi x square times x. Okay, now if this is x square into dx, this will be 1 upon 3 pi x cube minus pi plus pi. Now if you would put the value of this x equal to pi, this will be 1 upon 3 pi pi cube plus pi. So this will be pi square by 3. So a0 here will be 2 pi square by 3. Right? Now come to the second part, that is an. Now an here will be 1 upon pi minus pi to plus pi fx cos ax into 2, and this will be 1 upon pi minus pi to plus pi x square of x. Right? Now if you integrate this term by parts, what you will get? You will get this will be 1 upon pi, and you use the formula of I get, that means algebraic function and geometric function. Obviously, algebraic function is the first function, so this will be 1 upon pi x square. Now integrate the second function cos ax into dx, and this will gives me sin nx divided by n. Obviously, if you put this value, this between the value of minus pi to plus pi minus differentiate of this term. So this will be 2 by pi. Now if you differentiate this term, this integration will be minus pi to plus pi. This will be x, and obviously integration of the second term. So this will be again sin x. Right? Now if you put pi here, what are the value of this pi? Now try to integrate the, now what is the value of this pi? If you put the pi as a sine function, obviously this is So twice minus 2 divided by 5. If you integrate this term, first function will be x. So this will bring me x into sine will be cos nx divided by x square minus 5 plus 5. Now if this is cos nx by n square minus 2 divided by 5 sine x minus 5. So sorry, this will be n square and this will be integration, then we can so this again. So the second term which I get here is again gives me 0. And a term which survive only 2 times minus 2 divided by 5. If you put pi here, this will give you minus 1. So for value of this n, and if you put minus 5, this will give me again plus 1. Okay. So 2 by 5, both the terms, so this will be twice pi divided by x square, and the value of this cos nx, this will be minus 1. So this gives me 2 by x square minus 1. Sorry, there will be no minus because cos pi equal to minus 1, so this minus again. So again, 4 by n square minus 1 because n is an integer. So you get the value of this n as 4 by n square minus 1. Now the value of this n will be minus pi to plus pi 1 upon pi. So fx sine nx into dx. So this will be 1 upon pi minus pi to plus pi x square sine. Now if you integrate this term in same form using integrate formula and integrating this by parts, we will get that this will be 0. If we expand this term in a similar way as I have done in case of cos function, we will get the value of 0. So the value of this being is 0. So I get the value of this 3 coefficient here. We have to just write this Fourier series in terms of this 3 coefficient, and what we will get fx, because this is 0 by 2, so this will be pi square by 3 plus sum over n equal to 1 to infinity 4 by n square minus 1 over n or right. So this x square, sorry, x square here. So fx equal to x square is. So I can write this term for what are the value of this n. N will be 1 to n. This function obviously expanded between minus pi to plus pi. in this series, if you put x plus y, what is the outcome? This will be y squared, and this will be y squared by 3 plus sum over a equal to 1 to infinity 4 y x squared minus 1 to the power n cos. Okay. Now, if you put cos n pi, this will again become minus 1 to the power n. So, this gives me minus 1. So, cos n pi equal to minus 1 to the power n. So, this will be minus 1 to the power twice n. And if you expand this, so this minus 1 to the power twice n, as this is even function, so this term always remains plus minus 1. So the a equal to 1 to infinity 1 by n square, this will be I square minus I square by 3, and this gives me I square by 6. Right? So I write off summation, that is sum over n 1 to infinity 1 upon n square is equal to 1 square by 6. Okay? For today, after this, we will come to the second portion of this Fourier series in the next class.